We're going to be learning about the behavior of gases this week. Now, the pressure of a gas is a force per unit area that the particles exhibit on the walls of their container. More air particles inside a ball means more mass inside. So think about a ball or a balloon, and you have all of these particles in there. The more you have, the more mass you have in here. And the more they're moving around and the more they're bouncing off the walls. And as they bounce on the walls, they exert a pressure. Now, the pressure of a gas is directly proportional to its mass and to the number of particles. So if we have pressure, as the pressure goes up, its mass goes up, and the number of particles increases. It's a direct relationship. Now, pressure is caused by the force of gas molecules striking the walls of its container. The more often the collision, the greater the pressure, just like here in this drawing. Now, the higher temperatures cause higher pressure, provided that the number of particles and size of the container remain constant. If the gas is permitted to expand as the temperature increases, the pressure is going to remain constant. So here we have the temperatures increased, but the volume is constant. So let's do this. So here, if the temperature increased, volume's constant, you have increased pressure. Here, it says if the volume's decreased, so here the volume's decreased, the area, of course, decreases, and that means the pressure increase if the temperature is constant. So here, volume constant, you could see the visual there, temperature constant, which means there's no change in temperature. With here, you have the container pressure is constant, so pressure is constant, but you're increasing the volume because more gas molecules are being added. But basically, they say if you allow the gas to expand as temperature increases, you're not going to have a change in pressure. This is one thing that we know about. If we keep the volume fixed, though, and we increase temperature, the pressure will increase. Now, the barometer is an instrument that measures the pressure by the atmosphere. So we live at the bottom of an ocean of air. So here we are on Earth's surface, and we have all of these air particles pushing down on us. Just because we can't see it doesn't mean it doesn't have mass and is pushing down on us. So that means that the highest pressure is close to the surface of the Earth. So this is where pressure is the highest. Up above, where you don't have all the particles necessarily on top, think about the ocean. If you go deeper in the water, you have more pressure on you because all that water above you is pushing down. Same thing happens with air. At the highest altitude, so if we're at a really high mountain, if we're right here, we're going to have very little air pressure comparatively. because the pressure decreases as you go up the mountain. There's less of the particles pushing down on you. Think of it like layers of a blanket. Here you be under 10 different layers. Here you might only have 2 different layers. Standard atmosphere is a pressure that supports a 760 millimeter column of mercury, and it's represented as 1 atmosphere pressure equals 760 millimeters mercury. Now, atmospheric pressure is sometimes called barometric pressure. If you are watching the weather and they say the barometric pressure is dropping, that typically means that a storm is coming. So we watch the air pressure to be able to predict the weather. They say, oh, look, there's a high pressure front coming in or a low pressure front coming in. So that way you can say, oh, what will the weather be like based on this weather pattern? Here's what a barometer looks like. This has millimeters of mercury in it. And based on the air pressure, this will change. The volume will change because this is a closed system. So we're either allowing the pressure to expand, or the volume will expand, or it will decrease based on the outside pressure. Now, barometers can only measure atmospheric pressure, so other types of devices are needed. If we want to measure pressure in your tires or in a ball or in other capacities. Now, pressure gauges are used to measure pressure with a tire or a tank, and tire pressure is above atmospheric pressure. So you will have like 32 pounds per square inch is an average tire pressure depending on what type of tire it is. Now, barometers measure absolute pressure, which is the total pressures exerted by all the gases. So to find the absolute pressure of the tire, you have to add the gauge pressure to the atmospheric pressure. So barometers is the absolute pressure, and that's the total pressures. So if you wanted to know the absolute pressure of the tire, say it was 32 psi, you'd have to add that to 14 psi to know the absolute pressure of the tire. That's what that means. The tire gauge is only measuring the pressure within the tire itself. It's not the total pressure with the atmospheric pressure added onto it. Now, there are different units for pressure. Atmospheric pressure usually is measured in millimeters of mercury, and it's force per unit area. A Pascal is a small unit used to measure pressure as well. Then you have a kilopascal, which is 1,000 pascals. It's like a gram and a kilogram. And kilo always means 1,000. So one thing that you should know is that 1 atmosphere of pressure is equal to 101.3 kilopascals, which is equal to 760 millimeters of mercury, which is equal to 14.7 pounds per square inch. So if you have a tire pump, typically it's in pounds per square inch. If you have a barometer, you're going to see in millimeters of mercury. You can convert from one to another, but this just gives you kind of an understanding of you can measure pressure in whatever capacity, but you can always convert it from one unit to another. Now, in weather reports, barometric pressure is often expressed in inches of mercury. What is one standard atmosphere in inches of mercury? So let's think what we know. We know that one atmosphere pressure, based off of the conversions we were given, is 1.00 atmospheres, is equal to 760 millimeters of mercury. Well, we know that 1 inch equals 24 or 25.4 millimeters. So we want to know what one standard atmosphere is in inches of mercury. So we're going to take our first, we've got to convert our 760 millimeters into inches. So we're going to take our 760 millimeters times by what we want on top, which is our inches, and we divide by what we want to get rid of, which is our millimeters. Our millimeters will cancel. We know that 1 inch equals 25.4 millimeters. So now we take 760 times 1 divided by 25.4, and we get 29 inches. If you have questions, let me know. We're just doing lots of practices today, kind of trying to remember what everything is. Now, here we have the reading of a tire pressure gauge is 35 psi. What is the equivalent pressure in kilopascals? So we know that there are 14.7 psi equal to 101.3 kilopascals. That is from the previous slides. Whenever I gave you all those conversions, this is one of them. We have to say, all right, what are we given? 35 psi. So I'm going to start with 35 psi. That's what I'm given. What do I want to turn it into? I want to turn it into kilopascals. So kilopascals goes on top because that's what I want to turn it into. What do I want to get rid of? That would be PSIs. I know from my conversion factors that there are 101.3 kilopascals for every 14.7 PSIs. My PSIs cancel out. We have 35 times 101.3 divided by 14.7. And this gives me 241.2 kilopascals. Remember, you always put what you want on top. What you want always goes on top. What you want to get rid of always goes on the bottom. Because if you are dividing anything by itself, it cancels out. Anything divided by itself is 1. Make sure you show your work so that way you can keep track of it. Here, we have what is the equivalent of 1 atmosphere in millimeters of mercury. Convert 2 atmospheres to kilopascals. And a pressure of 500 millimeters of mercury is equal to how many atmospheres? I want you to take a moment, try these out on your own, and then come back and check your answers. So let's look at this. We have 1 HEM is equal to 760 millimeters of mercury, which is also equal to 101.3 kilopascals, which is equal to 14.7 psi. That I'm just putting up there for reference so that we have it off the top of our head and we don't have to go back. You do have these in your guided notes. I suggest that you go through your guided notes and write all of this down because there is a connection between writing and taking notes and remembering. Now, what is the equivalent of 1 atmosphere in millimeters of mercury? So I am given 1 atmosphere. So I say 1 atmosphere times what do I want? I want millimeters of mercury. What do I want to get rid of? I want to get rid of atmospheres. Atmospheres cancel out. We know that there are 760 millimeters of mercury for 1 atmosphere. 1 times 760 divided by 1, 760 millimeters of mercury right here. That's B. Let's look at 2. Convert 2 ATM to kilopascals. What am I starting with? 2 atmospheres. What do I want it to turn into? Kilopascals. Look up here at my conversions. How many kilopascals? 101.3. How many atmospheres is equal to 101.3? That would be 1 atmospheres. Atmosphere goes on the bottom because I want to cancel it out. So then it's 2 times 101.3 divided by 1. That gives me 202.6 kilopascals. Now, 3, a pressure of 500 millimeters of mercury is equal to how many atmospheres? All right, what are we starting with? 500 millimeters of mercury. What is it we want to turn it into? Atmospheres. Whatever we want to turn it into goes on top. Whatever we want to get rid of goes on bottom. Now I look up here, millimeters of mercury, atmospheres. There's 1 atmosphere for every 760 millimeters of mercury. My millimeters of mercury cancel out because I have 1 on top, 1 on bottom. That gives me 500 times 1 divided by 760 gives me 0.66 millimeters of mercury. So the answer is A. If you have questions, let me know. I am always happy to help. Have a great day.